Hello. In this video, we're going to continue our study of the binomial theorem. Let's expand x minus 3 to the power of 4. Well, if you remember, we can draw our little triangle. Pascal's triangle is going to give us the coefficients right here. So we start with 1, 4, 6, 4, and 1. Then we take the x and we count down, x to the 4, x to the 3, x to the 2, x to the 1, x to the 0. Then we take the negative 3 and we count up. Negative 3 to the 0, negative 3 to the 1, negative 3 to the 2, negative 3 to the 3, negative 3 to the 4. Then we go ahead and multiply each one of these to get our final term. So this will be x to the 4. Here we'll have negative 12x to the 3. Then we're going to have, well, 3 times 3 is 9, makes a positive. 9 times 6 is 54, x squared. Negative 3 times negative 3 times negative 3 is going to be a negative number. That's going to be negative 27, and then times another 4. So negative 27 times 4, negative 108. And then positive 81. All right, so that's a quick refresher for how the binomial theorem works. But what I want to do in this video is focus in on a slightly different question. How would you find the fourth term? Now, if you look here, the fourth term is just, well, right here, right? You could count first term, second term, third term, fourth term. Oh, it's right there. The fourth term is negative 108x, boom, box your answer, and you're good to go. But how would you find the fourth term without expanding the whole thing? That's what we're going to focus on in this video, because believe it or not, there's actually a shortcut to this shortcut, right? The binomial theorem is a shortcut for expanding x minus 3 to the power of 4. Instead of having to FOIL it out and FOIL it out and FOIL it out, you can use this shortcut with Pascal's triangle and with the counting up, counting down to get the full expansion without actually having to multiply. The only thing is that this shortcut, while technically being faster than x minus 3, x minus 3, x minus 3, and x minus 3, I mean, technically it's faster than multiplying all that out to get our final answer, but it's still not very short. And so we need a even more shortcut, a shortcut, if you will, because we're only looking now for just the fourth term. And so is there some way to get just the fourth term without having to do all the other work? And if you take a look on your formula sheet, indeed there is. The formula sheet should have something like this. tk plus 1 equals nck a to the n minus k, b to the k. Now, what in the world does that mean? Well, this is the way to find any specific term from the expansion of a plus b to the power of n. So in our situation, we had x minus 3 to the power of 4. And we need to identify what each letter is and then plug them all into our formula. So let's look at the first one here. A is equal to x. A is just the first letter in the binomial. And b is equal to negative 3, the second letter or number in the binomial. N is equal to 4. It's the power on the binomial. But k is a little tricky. K is what you need for the term, and so you might say, oh, well, k is 4 because you need the fourth term. But if you try that in the formula, you'll get t4 plus 1, which becomes t5. And so k isn't actually the term you need. K is 1 less than the term you need. It's almost a little bit of trial and error here, because we want t4, which stands for term 4. To get that, we need to have 3 plus 1, which equals 4. And k needs to be 3. So this one you need to choose. You choose k. The other letters just come right from the expansion. So we're looking to expand x minus 3 to the 4. So a is automatically x, b is automatically negative 3, n is automatically 4. But k you get to choose, and whatever you choose gives you the term, and hopefully the correct term. So let's go ahead and take a look here. we should have n, which is 4, ck, k we've chosen to be 3, then a is x, n minus k, all right, 4 minus 3, and then b is negative 3, and k is 3. My goodness, a lot of different things we need to substitute in there, but again, as long as we just take all these values, substitute them into the formula, we should be good to go. Now, for most of these questions, you will have access to a calculator, so you can type in 4c3 on your calculator. 4c3 will be 4. X to the 4 minus 3, well, that's x to the 1. And negative 3 to the power of 3 is negative 27. 4 times negative 27 is negative 108x. And if you look, that's the same as we had right there. And it's definitely shorter than before. The first time you do it, it feels a little bit harder because you have this weird term formula. But once you get the hang of using it, it's definitely shorter than the other method. And it's on the formula sheet, which is all of the bonus because you don't really have to memorize anything for this one. You don't have to construct a triangle. You just take the numbers and plug them all in to the formula. All right, so let's go ahead and give it a try. Let's find the fifth term in the expansion of 3x plus 4 to the power of 7. Again, I'll write down the term formula here in case you don't have it. It's tk plus 1 equals nck, a to the n minus k, b to the k. So go ahead and pause the video and give it a try. All right, so we should have n equal to 7 because of that 7 right there. A is 3x, b is 4, and I think we need k. To get the fifth term, we should have k equal to 4. T4 plus 1, yeah, that'll be 5. All right, so let's plug everything in. 7c4, 3x to the 7 minus 4, 7 to the, oh, sorry, not 7, 4 to the 4. All right, calculator time. 7 C4 is 35. 7 minus 4 is 3, so here we have 3x to the 3, and then 4 to the 4. Now, 3 to the 3 will be 27. 3 to the 3 is 27. And then the 3 also goes on the x. So it's kind of like 3 to the 3 and 3 to the 3 goes on the power of 3 and the 3 goes on the x of the power, so you get 3 to the 3x to the 3. Now 4 to the power of 4 is 256. And then because everything's multiplied, we can just group all these numbers together. So on our calculator, we can do 35 times 27 times 256. And that'll give us 241,920 x to the power of 3. All right, now just for fun, we can check the expansion. I'm not going to do this myself, but I'm going to go ahead and pull up a supercomputer. I'm going to do it on Wolfram Alpha, and we'll check to see that the fifth term is indeed this thing. All right, so here we see the expansion of our binomial, and we can see term 1, 2, 3, 4, 5. There we have our term number 5. And indeed, that's exactly what we have with our term formula, 241,920 x to the power of 3. And again, we were able to just pluck off that fifth term without having to do the full expansion. Now, of course, if you forgot the term formula, I mean, it's on the formula sheet, but if you forgot to use it or just panicked and you did the full expansion and got all 8 terms and then picked the fifth term, that would still be correct. It would just be a very long way of answering the question. So you could fall back on that as a backup method if you needed to. You could expand the whole thing and just grab the fifth one, but it's not very efficient, and that's why we're learning this term formula. Now, speaking of not being efficient, I mean, look at this binomial. We have 2x minus 3 to the power of 20. Because it's the power of 20, we're going to get 21, always one more than the power, 21 terms. I mean, no one wants to expand this just to find the third term. it's definitely going to be more efficient to use that term formula. So I'd encourage you, go ahead and pause the video, use the term formula, and see what you come up with. All right, assuming you gave that a try, we should have t, well, let's see, n is 20, a is 2x, b is negative 3, and to get the third term, k will be 2. 2 plus 1 equals 20, c 2, 2x to the 20 minus 2, negative 3 to the 2. And we need our calculator for the 20c2. That's 190. Here we have 2x to the 18. Here, I guess we could do this as a 9. Now remember that 18 is going to power both of those. So that's 190 times 2 to the power of 18. Well, that's going to be pretty big. That's 262,144. X to the 18 times 9. Now again, we can group all of these numbers together to get our final coefficient. Because we're multiplying, we can do it in any order here. So this should give us a final value of 448,266,240, x to the power of 18. All right. Let's try a few more examples, these ones with a little bit of a trickier binomial. Here we have 2x plus 7y. So notice we've added variables to both the first and second part of the binomial. We're looking for the second term, and then we'll also find the third term in a moment. But let's focus on that second term of this to the power of 5. Pause the video and give it a try. All right, I'm just going to jump right into it here. We have n equals 5, a equals 2x, b equals 7y, and k equals 1. t1 plus 1, 5c1, 2x to the 5 minus 1, 7y to the 1. Now some of these you might know. 5c1 I know is just 5. 2x to the 4. 7y to the 1 will just be 7y. 2 to the 4 is 16. So you have 5, 16, x to the 4, 7y. Now again, it's nice to group the numbers. So the 5, the 16, and the 7. We want to group all of these in the front. So that's 560. X to the 4, y. Now, just in terms of a convention, usually we write these letters here in alphabetical order. So we go A, B, C, D, E, and so on. So x comes before y, so we write x to the 4 and then just the y. But if you wrote it y, x to the 4, that's still okay. This is still correct. It's just not the usual way you'll see it in the answer key. But again, because it's multiplication, you know, x times y is the same as y times x. But just so you know, we usually write them in alphabetical order. All right, let's find the third term in this expansion. Now to find the third term, everything is the same, except k will now be equal to 2. But the rest of this remains the same because we still have the same binomial we're expanding. So pause the video and give that a try. All right, so we should have t2 plus 1 equals 5c2. 2x to the 5 minus 2, 7y to the 2. That's going to give us 10, 2 to the 3, x to the 3, 7 to the 2, y to the 2. Again, this is going to go to both the 7 and the y. Now we can group all these numbers together. 10 times 2 to the 3 times 7 to the 2 as 3920, x to the 3, y to the 2. And there's our final answer. All right, determine the third term in the expansion of x squared plus 3 over x to the power of 6. So pause the video and give it a try, and just be careful with this second term. When you're looking for all of your exponents and you're simplifying everything, just be careful. All right, assuming you gave that a try, let's go ahead and set it up. We have n equal to 6, a is x squared, b is 3 over x, and we're looking for the third term, so k is 2. All right, t2 plus 1, 6c2, x squared to the 6 minus 2, 3 over x to the 2. 6c2 is 15. This is x squared to the 4, 3 over x to the 2. Now, we can see this gets a little tricky because we have x to the 2 to the power of 4. This is an exponent rule type situation. When you have power to a power, you multiply, so 2 times 4 is 8. This is going to give you x to the 8. We'll review those rules in just a minute if you forgot that. Now here, the 2 has to go both to the 3 and to the x. So you're going to get 3 squared, which is 9, over x squared. Now the 15 and the 9 can be combined to give you 135. So here, let me do that like this. The 15 and the 9 can be combined to give you 135. But we also have to combine the x to the 8 and the x to the 2. Remember, when you have an x on the top and the x on the bottom, the way we work on these is we subtract their exponents. So you get x to the power of 6. It's like x to the 8 divided by x to the 2, which is x to the 8 minus 2, x to the 6. All right, so this will be our answer. But let's go ahead and review those exponent rules, because there were a couple things here that might have thrown you. So if you had x to the 3 times x to the 2 in your simplification, this is going to become x to the 3 plus 2, or x to the 5. You have to remember that when you have the same base here, and you're multiplying, you can add. So the multiplying here becomes an addition of those powers. If you had x to the 3 divided by x to the 2, that's going to be x to the 3 minus 2, or x to the 1. Because if you're dividing, that becomes subtraction. If you had x to the 3 to the power of 2, that's going to become x to the 3 times 2, or x to the 6. Because if you have power to a power, that becomes multiplication. You've got to watch for those exponent rules because they're going to be showing up here in our simplification. The same thing, I guess, we've already been doing, right? If you have 3x to the power of 2, that 2 has to hop on to both the 3 and the x to be 3 squared and x squared. And it also works in the division case. If you have 3 over x to the power of 2, that 2 has to hop on the 3 and the 2 has to hop on the x to give you 3 to the 2 over x to the 2. All of these exponent rules are really important to keep in mind as we're simplifying to find the final term. Okay, now I want you to find the 5th term in this expansion. And again, make sure you're watching those exponent rules. So go ahead and pause the video and give it a try. All right, so we have n equal to 6. A is x squared. B is 3 over x. And k will be 4. T4 plus 1. 6c4. X squared to the 6 minus 4. 3 over x to the 4. Now again, we have our calculator handy, so 6c4 will be 15. This will be x squared to the 2. 3 over x to the 4. So let's watch those exponent rules. X squared squared becomes x to the 4 because the 2 times 2 becomes 4. Now here we're going to get 3 to the 4 over x to the 4 because this needs to hop down on both. So we can group the 15 and the 3 to the 4. 15 times 3 to the 4 will be 1215. So this is 1215. And then x to the 4, oh, this is weird. This is kind of like, well, we have x to the 4 divided by x to the 4. which is x to the 4 minus 4, which is x to the 0, which is just 1. So we just get 1215. The x actually disappears, and the fifth term has no x's in it. Okay, kind of interesting, kind of neat. But remember, there are terms in your expansion that don't have any x's. So in this case, looks like the fifth term had no x. All right, let's do one last question here. Let's find the seventh term of 3x squared minus 2 over x squared to the power of 8. Please pause the video and give it a try. All right, n equals 8. A equals 3x squared. B, negative 2 over x squared. And k is 6. So we get t6 plus 1 equals 8c6. 3x squared to the 8 minus 6. Negative 2 over x squared to the 6. All right, there's a lot of steps to simplify here, so we want to take our time. 8c6 is 28 on our calculators. 3x squared, we can do the 8 minus 6 to get 2. This will be negative 2 over x squared to the 6. Okay, so the 2 is going to go on the x squared and the 3. Here, the 6 is going to go on the negative 2 and the x squared. So this will give 28 times 3 squared, x squared squared, negative 2 to the 6, x squared to the 6. Okay, well, we can group these numbers together. We'll group this one, and this one. We'll group all those together. So 28 times 3 squared times negative 2 to the power of 6. That's going to give us 16128. Now the x squared squared is going to be x to the 4. And then I guess we'll put this x on the bottom. This will be x to the 12. So we get 16128. X to the, well, 4 minus 12 is negative 8. Now, generally, we don't like to leave our answer with a negative exponent, so the more correct answer would be 16128 divided by x to the 8. In case you forgot, this is yet another exponent rule. X to the negative 3 becomes 1 over x to the 3. Or if you have 1 over x to the negative 5, that becomes x to the 5. You can swap the location of the x, whether in the top or in the bottom of a fraction, and then you flip the sign on the exponent. So if it's down in the bottom as a negative, it comes up as a positive. If it's in the top as a negative, it goes to the bottom as a positive. So in this case, we have it in the top as a negative, so it goes down to the bottom as a positive. Or you can think about it that the negative exponent just means division. So you got to take this and put it on the bottom. Now, we just need to be careful again, making sure that this answer is correct. And so what I want us to do is check this out on Wolfram. And our answer is correct, but there's just going to be a little technicality that I want us to be aware of. All right, so if we look at our expansion here, we can indeed see that our term 16,128 over x to the 8 is in the expansion. But technically, the way Wolfram has listed it, it's term 1, 2, 3, 4, 5, 6. And we were actually looking for term 7. Now the thing is, when Wolfram does the expansion, sometimes it just puts them in a different order. There are 9 terms, and so it's the correct expansion, but it's done them kind of weird. It's sort of like grouped the x to the 16 and then x 1 over x to the 16. It's kind of grouped them side by side, and it hasn't just expanded them the way we expand them. This is a little frustrating, but you know, when you're looking up things on random websites, sometimes different programmers have taught the computer to do math slightly differently. And so while the value of our term is correct, it's in the wrong location to where we would consider it. We would actually put this term 1 over because it's the 7th term. And so just as that technicality to be aware of, if you're checking your answer online, sometimes it'll be in a different location. But as long as you're following the formula, you'll get the right answer for the way we're expanding it. So just keep that in mind. All right, let's go ahead and take some notes on this. So this is the binomial expansion, but we're using the term formula. So basically, this is the term formula. And so the term formula is tk plus 1 equals nck, a to the n minus k, b to the k. And this expands for a binomial a plus b to the power of n. So you can see there's the a, there's the b, there's the n, and you choose k. You choose k to get the correct term. So for an example, let's find the fifth term of 2x minus 6 to the power of 5. So go ahead and pause the video and give that a try. All right, so we should have t5, which means we need t4 plus 1. K needs to be 4. 5c4, 2x to the 5 minus 4, negative 6 to the 4. And so that should work out to 12,960 x. Now for practice, you can try worksheet 12 and 12.5. You can go ahead and maybe put one of those examples here in your notes, and then write down any things to remember. Probably the most important things to remember here that are new are, of course, that you have to choose k or the exponent rules. So if your exponent rules are a little rusty, particularly the ones with the negative exponents or powers to a power, maybe just write down some of those exponent rules real quick so you have them handy. That way you can simplify these and get the correct answer. All right, hopefully you enjoyed this video, and as always, thanks for watching.